You're strapped in. The wind whips past your face. Hundreds of feet above the ground, you stare down a dizzying drop. Then the plunge. Your stomach leaps into your throat. You're weightless, breathless, and totally alive. This is the magic of a roller coaster, a carefully orchestrated symphony of steel and thrills. But behind this whirlwind of excitement lies a fascinating world of science, engineering, and design. It's a world where physics isn't just a subject in a textbook. It's the driving force behind every heart-stopping turn, every stomach-churning drop, and every moment of pure, unadulterated joy. So buckle up and hold on tight as we dive deep into the thrilling science behind roller coaster design. We'll unravel the mysteries of these gravity-defying marvels and discover how engineers transform physics into pure exhilaration. Get ready for a wild ride. Every roller coaster, from the tallest, fastest behemoths to the tiniest, twistiest family coasters, begins with an idea. Imagine a blank sheet of paper. Designers sketch, dream, and scribble, their pencils dancing with the energy of 1,000 screaming riders. They envision daring drops, stomach-flipping inversions, and mind-bending turns. But it's not all wild imagination. These coaster visionaries blend their creativity with cold, hard math. They calculate speeds, angles, and forces, ensuring the ride is thrilling but safe. Computer simulations bring their ideas to life, allowing designers to experience the ride virtually. They tweak and refine, testing different layouts and elements. It's a meticulous process of trial and error, where every curve and slope is carefully considered. Only when the design is perfect, when the thrills are maximized and safety is paramount, does the dream start to become reality. The blueprints are finalized and the construction of a coaster masterpiece begins. Roller coasters are more than just steel and screams, they're exhilarating physics lessons in disguise. At the heart of every thrilling ride lies a fundamental force: gravity. This invisible hand pulls the coaster down those first terrifying drops, building up speed and energy. As the coaster races along the track, it's a constant dance between gravity, inertia, and momentum. Inertia wants to keep the coaster moving in a straight line, while momentum carries it forward. The track, carefully engineered, manipulates these forces, throwing riders into a whirlwind of sensations. Loops, helixes, and corkscrews, these aren't just there to look cool. They're carefully calculated maneuvers that exploit centrifugal force. This outward push, generated as the coaster changes direction, keeps riders plastered to their seats, even when they're upside down. Every twist, turn, and drop is a carefully choreographed physics problem designed to deliver the perfect balance of fear and fun. It's this interplay of forces, this mastery of physics, that makes roller coasters a thrilling testament to human ingenuity. Building a roller coaster is no small feat. It's a monumental undertaking, requiring the precision of a surgeon and the strength of a titan. Tons of steel, meticulously fabricated, form the backbone of the ride. These aren't your average girders. They're crafted to withstand incredible stresses and strains. Massive cranes, like mechanical giants, hoist these steel sections into place piece by piece. Welders, masters of their craft, fuse the pieces together with fiery precision. The track, often laid out on the ground first, is a tangled metal serpent, waiting to be unleashed. But it's not just about brute strength. Lasers and surveying equipment ensure pinpoint accuracy. Every bolt, every weld, every inch of track must be perfect. Lives literally hang in the balance. As the coaster takes shape, it transforms from a jumbled mass of steel into a recognizable icon of thrill. The iconic lift hill rises, a beacon of anticipation. The track twists and turns, promising a symphony of screams. Safety first, thrills second, keeping riders secure. Before a single rider can experience the adrenaline rush, it undergoes rigorous testing. Engineers become temporary test pilots, outfitted with sensors and data recorders. They brave countless circuits, pushing the ride to its limits. Wheels are checked for wear and tear. Brakes are tested again and again. Harnesses are examined for the slightest imperfection. Safety is paramount. Nothing is left to chance. State-of-the-art systems monitor the ride in real time. Highly trained operators ensure a safe and exhilarating experience. This commitment to safety allows us to surrender to the thrill, knowing we're in good hands. The human factor: why we crave the drop. Why do we subject ourselves to these scream-inducing, G-force-defying contraptions? Why do we queue for hours, anticipation bubbling in our stomachs for a few minutes of pure, unadulterated adrenaline? The answer lies deep within our primal instincts. Roller coasters trigger our fight-or-flight response, flooding our brains with adrenaline and endorphins. This biochemical cocktail creates a sense of euphoria, a natural high that keeps us coming back for more. But it's more than just chemicals. Roller coasters offer us a sense of controlled danger, a safe space to confront our fears and push our limits. We scream, we laugh, we raise our hands in triumph, conquering our anxieties with every heart-stopping drop. It's a shared experience, a communal embrace of fear and exhilaration. We emerge from the ride, legs wobbly, hearts racing, bonded by the shared experience of cheating gravity and staring fear in the face. Beyond the blueprints, the art of coaster design. Designing a roller coaster is more than just physics. It's an art form. It's about crafting an experience that stays with riders long after the ride is over. The best coaster designers are storytellers, using steel and speed to weave tales of adventure. Theming transports riders to different worlds. One minute you're racing through an Egyptian tomb, the next you're soaring through a prehistoric jungle. Sound effects, music, and even smells enhance the immersion. A well-designed coaster is a roller coaster of emotions, with moments of quiet anticipation building to heart-stopping drops and inversions. It's a delicate balance, like composing music, with each element working in harmony to create a thrilling whole. The best roller coasters are more than just rides. They're unforgettable experiences that stay with us long after we've stepped off the platform. The future of fright innovations in thrill rides. The world of roller coasters is constantly evolving, with designers and engineers constantly pushing the boundaries of what's possible. New technologies are emerging, promising even more immersive, more intense, and more mind-blowing experiences. Imagine strapping into a coaster that launches you from 0 to 60 miles per hour in seconds, using electromagnetic propulsion. Picture yourself soaring through virtual reality landscapes, battling dragons and exploring alien planets, all while your body is subjected to real-world G-forces. Augmented reality could overlay digital elements onto the real world, blurring the lines between fantasy and reality. Imagine seeing dinosaurs roaming around the park or battling spaceships in the sky, all while hurtling along a steel track at breakneck speeds. The possibilities are endless, limited only by our imaginations. As technology continues to advance, so too will the roller coaster, promising a future filled with bigger, faster, and even more exhilarating thrills. The last drop, a legacy of thrills. As we reach the end of our journey, we appreciate the intricate science, engineering, and artistry behind roller coasters. These scream machines are testaments to human ingenuity and our endless pursuit of thrills. From the first drop to the final brake run, roller coasters push us to our limits, leaving us breathless and exhilarated. If you found this video interesting and want to discover more about how things are made, built, explored, discovered, or manufactured, be sure to give this video a comment, a like, and subscribe to Manafacta.